welcome you for coming to our conference, and we will be starting our session, the undergraduate student session. The first one will be Noran and d.منه. The topic will be Little Clay, Big Difference. And please, would everyone introduce her or himself, please, before starting? You have 15 minutes, 10 minutes is the presentation, and 5 minutes for the questions.
I want to thank you all for coming in here today. Our title is Little Clay, Big Difference. It's a review for an article or a paper that me and my colleague worked on to present it today. My name is Bيسارو. My colleague is Zoology. We're third-year students at the Faculty of Science, Cairo University at the Biotechnology Department. Well, our title or our presentation as a whole is talking about bioremediation. But why is bioremediation so important to our lives, oil bioremediation? This would be the view without bioremediation. With oil, the industry is going so well, and oil is just leaking everywhere. The first picture on the top is from Mexico, the Mexican Gulf. This picture is from the Red Sea here in Egypt. And this mass kill, this worst mass kill ever of fish is also due to oil leak or oil spills. Also, this is from the Mexican Gulf as well. So this is how our life would be without bioremediation. So let's talk further about bioremediation. Mainly, we'll have to discuss one thing, that oil will be over the sea. Bacteria that God puts in nature is not able to get through this oil and try to eat it, the oil-eating bacteria. So we first add dispersants so that they can just emulsify these oils and make it oil droplets to increase the surface area for the reaction of the bacteria. And the next one is the reaction of the bacteria. We have to make sure, as an idea, that oil is mainly composed of hydrocarbons. So the oil-eating bacteria takes in the oil with oxygen and gets it out as water and carbon dioxide, which are less toxic material than oil, of course. And by adding fertilizers, the bacteria work better or work more fine. Also, not all the oil is bioremediated or eaten. We have to keep in mind that there are micron-sized droplets of oil that remain. But everything that we're talking about here is limited to the bacteria. Bacteria that needs fertilizers to grow better and to eat more oil. So now our motivation was that we are working on this paper. This paper is discussing a spill that has been done in the Mexican Gulf, the sinking of the Deepwater Horizon platform. This spill was a disastrous one, happened on the 22nd of April 2010. The spill spread over 75,000 square kilometers. Also, 780 million liters of oil entered the Gulf of Mexico. After 7 months, which is a huge period of time, of course, I don't want to mention how many fishes have died during these 7 months. We're talking about 41% of the oil had evaporated, dissolved, or dispersed by natural means. As I said earlier, God puts in oil-eating bacteria. Also, 33 was captured, chemically dispersed, burned, or skimmed during bioremediation efforts. But it seems that it wasn't good enough, because 26% remained as a potential hazard. And these are the ones that our paper is discussing. Also, after investigating, we found that Egypt had something somehow close to this accident, Jebel al-Zayt oil spill, also in Egypt on the 16th of June 2010. This spill spread over 100 miles or 160 kilometers. 90% of the spill was cleaned in 5 days, leaving the worst impact on some species of fishes and coral reefs. This spill was cleaned by suction of the oil, by this machine that literally destroys all the coral reefs it's moving on. And now our title is called Little Clay clay, big difference. So the word difference indicates that we are talking about comparing two things together. The experiment that we're showing today had 3 different samples. The first one is called the control sample, which is oil and Gulf Coast water. Of course, we're talking about the Mexican Gulf here. It just resembles the nature. Oil-eating bacteria will just go there and start eating the oil. So actually, bacteria respired and oxygen decreased in this medium. The second one is the traditional way, which is oil, Gulf Coast water, and fertilizers, of course, to enhance the bacterial activity. And the last one, which is our topic today, is the new technique, which is oil, Gulf Coast water, and fertilized Fuller's earth clay, which we'll be discussing later in detail. 3 samples were subjected to the same conditions. The first one is oxygen flush twice weekly, also continuous shaking, so that it can resemble the sea waves. And the last thing, that the beakers were closed with caps, so that evaporation, there will not be any excessive evaporation. So now let's talk about the traditional way. We said in the control sample that bacterial respiration took place. But here, we are talking about a major increase in the consumption of oxygen. A brown turbid water with thick oil coating, as in the figure, that will just prove that more bioremediation has occurred. And the last thing, well, it's so far so good. Bioremediation has occurred, bacteria are respiring so well. Why do we need a new technique? Well, actually, we need a new technique because in open waters, fertilizers clearly disperse. The dispersion of the fertilizers will mean that 90% of the fertilizers that we'll add to open waters will just immerse in waters. We'll lose them. We'll have to add even more fertilizers for the bacteria to respire better. So, here's to the new technique. These are the magnificent clay flakes, the little clay, big difference. This is the little clay. Clay flakes are composed of fertilizers, filming additives, and organoclay. They're done as here in this picture. The homogeneous mixture of these 3 things is added to a plastic envelope, and then it's left to dry in air, and then this is their shape after they have dried, and they're ready for experiment use. These clay have low cation exchange, they are porous and fibrous, they have good absorption capacity for the organic molecules, so we just add the fertilizers to this clay, and they also have oil retention properties. The clay will attach to the oil and slowly immerse the fertilizers to the bacteria. We won't have to lose any fertilizers, and also we won't have to add any dispersants. So now this is the new technique. The results are the brown turbid water with oil droplets. Biofilm clay oil flocculates that slowly sink in the beaker as mud. Here it's shown in the picture. This mud, we want to make more research about this mud, that these fertilizers, it's fertilized mud, we need to try to cultivate it somewhere else. And it has the highest oxygen consumption, and of course a reduction in the toxic and mutagenic components by 25 to 45%. And now let's take a look on comparing the results together. The first sample, which is the control sample, had clear water with floating clumps of oil. The traditional way had brown turbid water, which shows, oh yes, it's got better. Bacterial respiration is better, bioremediation is better, but yet not good enough. And the last technique is a brown turbid water with oil droplets, which shows the best bioremediating effect. The alkane was reduced by 82.5% in the control sample, the traditional way was 95.8%, and in the new technique by 98%, which is the best one. And here in the polyaromatic hydrocarbon was reduced by 43.5% in the control sample, a 53.2% in the traditional way, and sadly a 41.7% in the new technique. But actually, when me and my colleague D.Nوران started reading about how to bioremediate polyaromatic hydrocarbons, we thought it was useless, but when we read about it, it's just adding some fertilizers to them, also bacteria will come and eat them. So, in our opinion, and it's not written in any paper, that if the scientists would have waited a little bit longer after the experiment, the polyaromatic hydrocarbons would have decreased by a percentage which is more than that. And now to the oxygen depletion curve, which indicates how many bacteria took consumption of oxygen in each experiment. In this curve, it's the control sample. Of course, the oxygen depletion curve is so wide And here, the black one is the fertilizer, oil, water, and the last one is the Fuller's earth clay sample. Of course, the bacterial oxygenation was the best one. And now to the conclusion, it's mainly a summary. This method is concentrating fertilizer in the oil overcomes the problem of nutrient dispersions. Of course, we do not have to add even more fertilizer. It's just one time in the clay flakes. This method can significantly enhance the rate of bacterial respiration, as seen and better than the other two samples. The third point is that despite the large reduction in alkane content, the polyaromatic hydrocarbons were introduced by the same effect. Of course, it's a disadvantage, but as I said earlier, me and Noran think if we stayed longer than the time of experiment, it would have been much better. And here, a large portion of the oil was converted to bacterial biofilm, which we want to try to cultivate it someplace else. And the last thing is a small quantity of oil formed as a micron-sized droplets on the film. And now here in Egypt, we want to apply this in Egypt. Everything that we're talking about in the Fuller's earth clay, it's okay. The mineral flakes are found here in Egypt with plenty of them. The only thing that we were missing is Fuller's earth clay. When me and Noran tried to search for many here in Egypt for import reasons or import studies and how many times do we import it, we didn't find it except on an Indian website that said that Egypt imported Fuller's earth clay 7 times in the past 6 months only, for other purposes, of course. But it's with an average of 622.5 Egyptian pound per ton. We only need 100 grams, for 100 grams of water and 5 grams of oil, we only need 0.5 grams of mineral flakes. The mineral flakes composed of Fuller's earth clay, fertilizers, and organoclay. So we only need 0.5 grams for mineral flakes, which is clearly much cheaper and, of course, more environmental friendly. From the ethical point of view, normally when you ask anyone, I want to enhance the bacterial activity, they start talking about genetic modification. So me and Noran said that we have to get away from the genetic modified organisms conflict, because it's sometimes people are trying to say is it ethical or not. The second thing is the mass kill of many forms of aquatic life. Of course, you've seen the pictures that we posted earlier. It's disastrous. And suction in Egypt, as I said earlier, that Egypt does suction of the oil. When an oil spill occurs, we start sucking it by some machines that literally destroy all coral reefs. And the traditional way, by using dispersants all over the world, we want to get rid of the oil, so we add more chemicals to the sea, which is clearly not okay. But here in Fuller's earth clay, what we add is what we take after finishing the experiment. So no other chemicals are added to the sea waters. That would be it. Thank you so much for listening. And now I would like to invite my colleague Noran to the platform so we can listen to the discussion.
Thank you very much for this excellent presentation and perfect in everything. And what I learned mainly, of course, we can discuss later, it's the innovation in the idea. It's not just taking something and reviewing as it is. There was an innovative part which is linking what happened there with here. The problem always, we discuss problems elsewhere and we don't try to link it here inside. So maybe with your project you can approach the authorities and give them the idea, which is, I think, much better than the suction. So this is innovation, this is what I call innovation, and excellent job. Any questions?
You know, if we can apply such approach for, let me say, contaminated water, not only was oil dispersed, but was let me say, polluted water. You know anything about this? The literature.
We didn't think about it when we talked about oil, because sucking it and trying to get rid of it out of the environment causes many disastrous impact on the environment. Other pollutants, we didn't think about it because this innovative idea wasn't applied in this field. Others are chemicals, so we need other type of bacteria. But here we are talking about oil-eating bacteria. We know it's fertilizers that we needed for bacteria, but different type of bacteria. Here it is oil-eating bacteria that needs specific types of fertilizers, many types, but specifically potassium, phosphorus, and nitrogen, which we add to the oil plate. But other
So it's not difficult to produce this clay flakes in Egypt.
No, it's not.
It's much cheaper, more economic, and more environmental.
I think we have to conduct our business work, research work in this field. This is fantastic.
Okay.
Any questions? There's one thing about the pollution in water we can use. Again, it's a naturally product. It is the effective microorganism, EMs we call. This is a really very nice subject to work on. And it cleans the polluted places. And again,
What it means that we are dealing with a huge amount of water.
yes, this is
Perhaps the scale you
EM.
can
No.
And God in the Red Sea, we told that if we go back, but this won't happen, we apply this method on the Jabal al-Zayt oil spill. And this area, Jabal al-Zayt, it always has many accidents of oil spill. That's why it is called Jabal al-Zayt.
The mountain oil.
Excellent, perfect. Thank you.
Any further questions?
Any questions?
Sehr vielen Dank.